on 2, day 2. It's called Conditions for Triangle Congruence. We're going to be answering the question, do I need to know every measurement? If you do know every measurement, and you have all 3 angles congruent to all 3 angles, and all 3 sides congruent to all 3 sides, are the 2 triangles congruent? Yes, okay? But you don't necessarily need all of the information. There's a couple instances where you only need some of the information. That's called triangle congruence, okay? So question 15 says, Jovan is looking for an even better method. He is looking at the set of triangles below. Jovan thinks that triangle EFG is congruent to triangle HIJ, but he is not sure if the triangles are drawn to scale. All right, so the first thing you're going to do is you're going to take this information and you're going to label the 2 triangles above with the following information. So the first thing they want you to do is find angle H. And at angle H, it's how many degrees? 68. So you're going to find H, and you're going to write 68 degrees. Angles are on the inside, so you're going to write it on the inside as close to angle H as you can. The next piece of information is that angle F is 25 degrees. So you're going to find angle F, you're going to write in 25 degrees. Then it tells you that angle J and the measure of angle G are 87 degrees. So find J, which is right here, 87, and angle G right here, you're going to label it 87. Then the last information is that side IJ and side FG are both 13 centimeters. So the I and the J are the 2 endpoints. So here's I and here's J. So the side in between them is 13 centimeters. And FG, here's F and here's G. So the side in between them is 13 centimeters. Okay, so that's all the information they've given you. So you're going to convince Jovan that these triangles are congruent. Okay, we just read about something called the Triangle Sum Theorem. So can we figure out what this angle measure is right here? Yes. Can we figure out what this angle measure is right here? Yes. By doing what? Subtracting the 2 that we know from 180. Okay, so if you start with 180 and you subtract 87 and 68, what do you end up with? Somebody needs their calculator punching it in. What did you get? What did you get? 155? Did you only subtract one of them? Oh, you want to start with 180 and subtract the 2 angles that you know. So you want to subtract 68 and you want to subtract 87. Yes, it's 25. So right here you're going to write 25 degrees. And if these 2 are 87 and these 2 are 25, what does this one have to be? 68. So write 68 degrees. Okay, so if you take 180, subtract the 68 and the 87, you're going to get 25 degrees. That means all the angles are congruent, and we have one pair of sides congruent, so the 2 triangles are going to be congruent. Write that down. All right, part C. How many pairs of corresponding angle measures need to be equal to be sure that the triangles are congruent? What's the most amount of angles a triangle can have? 3. So how many of those 3 need to be congruent to convince you that all 3 are going to be congruent? 2. At least 2 of them need to be congruent, because if you subtract those 2 measures from 180, that third angle is going to be the same as well. Okay? So you're going to say only 2 pair need to be congruent. And these 2 triangles are going to be congruent by what we call angle, side, angle. And the shorthand for that is ASA. Here's how it works. You've got the 87, the 13, the 25. You've got the 87, the 13, the 25. That 13 has to be in between the same two angle measures in order for it to be angle side angle. All right. I'm going to move this up to the top. You'll see it in just a second. There it is. You're still writing. All right. Question 16. Hold on everything, Jovan's team member Kiam says. I see two different situations where we know two angles and one side. Look at some sketches I made from the previous problem. And you can look up these in eTools when you get your Chromebooks open. But here is the drawings he made. It says the two triangles on the left have a corresponding side that is between the two corresponding angles. I call that angle side angle. But in the two triangles on the right, the corresponding side is not between the two corresponding angles. I call that angle side. Okay? So these two triangles on the left, you have the 87, 13, 25. 87, 13, 25. So angle side angle. Angle side angle. Versus the two triangles on the right, you have 68, 87, 13. 68, 87, 13. So that one's angle side. Angle side. Right? Do both of these conditions ensure the triangles are congruent? What do you think? To demonstrate the two triangles are congruent, which condition is valid? The angle side angle or the angle side condition? Are both conditions valid? You say yes, both conditions are valid. The Triangle Sum Theorem is going to pair all three angles for congruence. You subtract from 180, that's what you're going to get. All right? Part 17 says, based on your conclusions from this lesson, decide if each pair of triangles below is congruent. If they are congruent, write a congruent statement like, and it should look like this, triangle, and you can use the little triangle symbol, EFG is congruent to triangle HIJ. Give the congruence conditions such as angle side angle, and we only know two at this point. We know angle side angle, and we know angle side. Those two we know work. There are a total of 5 that are going to work, but we only know 2 right now. We're going to learn some more. And describe a sequence of rigid transformations that map one onto another. So the rigid transformations, like what we did on Friday with the key lock puzzle, who can tell me, there's 3, who knows at least one of them? Translation, reflection, rotation. Good. So we're looking for a translation, a rotation, or a reflection. All right, so let's look at part A. Part A, we've got this triangle where we have an angle of 40 and an angle of 40. We have an angle of 110 and an angle of 110. We have an angle of 30 and an angle of 30. So if we were going to say that these two triangles were congruent, we would have to say that it was by angle. Well, triangles that have angle to angle aren't necessarily congruent. Their sides could be proportional. They could be an enlargement or a reduction. We don't know what the sides are for sure. Okay, so this one, they may be congruent, but maybe not congruent. These are always in question, so we're not going to write a congruent statement, and we don't need to write what transformation occurred because we don't know if they're congruent or not because we don't know side measures. We have to know at least one side. Okay? Part B, we've got angle R is 150 and angle W is 150. It's teeny tiny, right? Can you guys read that? All right, we've got angle D is 10 and angle B is 10 degrees. Then we've got this side is 58.5 and this side is 58.5. Okay? So these two are going to be congruent by angle, angle, side, AAS. Okay? We go angle, angle, side, angle, angle, side. Okay? And the transformation that's happening, the first one, the most obvious one, is that it's reflected down. So this one is flipped this way or flipped that way, whichever way you want to say it. When you write your congruence statement, make sure you go in the same order. So if you start at the 150 over here, you have to start at the 150 over here. If you go to the 10 next, then you have to go to the 10 next, and then the one that's left over. So you want to say that triangle RDC is congruent to triangle WBY. All right? Part C. So on part C, we have the angle 80 degrees here and the angle 80 degrees here. Then we have the 35 here, but we don't have an angle measure here. So could this one be 35? Well, how can we know for sure? Our theorem. What's the name of our theorem we learned? They add up to 180. Fancy word for add is sum. So it's the triangle sum theorem. Okay? So if you subtract 80 from 180, you get 100. And then 100 minus 35 would be 100 minus 35 is what? 65, okay? So if this one's 35, that's got to be 35, and if this one's 65, that's got to be 65. So all the angles are congruent, so you can fill in a 65 here and a 35 here. Then you got to check that side. We have a side of 150 centimeters here and 150 centimeters here. But on this triangle, that side is between the 80 and the 35. If you look on this triangle, what side is it between? The 35 and the 60 side. Is that matching up? No. So you say they're not corresponding, so they're not congruent. It has to be the side that's between the same two angle measures. Okay? All right, part D. So this is the first time you've seen this. You see how these two triangles are drawn, where they're having this, what we are going to call shared side. This middle piece is part of both triangles. It's part of the triangle on the left, and it's part of the triangle on the right. The good thing about that is that it's congruent to itself, right? If it's one measure for this triangle, it's that same measure for this triangle. And so we say that side AC is congruent to side AC. AC equals AC. That's like saying 8 equals 8. Does 8 equal 8? Yeah. So AC is congruent to AC. So we already have one side that's the same measure. Then we have an angle of 105, an angle of 105, a 55. What do you think this one over here is going to be? We've got a 105. What is 105 subtracted from 180? 95. No. From 180. 75. And then 75 minus 20? 55. So you can write a 55 right here, which is the same as this one, which makes that one 20. So on the right, it's 55. On the left, it's 20. So that shared side is between the 55 and the 20, the 55 and the 20. So it's the same on both triangles. So we're going to say that these two triangles are congruent by angle, angle, side, or angle, side, angle, depending on how you look at it. And the transformation that gets this triangle to that triangle is a rotation. So it's picked up and turned, picked up and turned. Okay?